Hello, student. I hope that you are doing well. Welcome to my channel, Dr. Chemist 2025. Today, I want to answer this question. Some of the students asked this question, and I decided to record a new video about it. Why is NaCl soluble in water but MgO is not? You know that the NaCl is an ionic compound and the MgO in the ionic compound. And you know that the ionic compound tend to be soluble in water. But MgO is an ionic compound and is not soluble in water. In this video, I want to answer this question, why the MgO is not soluble in water and why the NaCl is soluble in water. I'm Hamid Reza Motifar. First of all, please subscribe this channel and hit the bell. When you hit the bell, you do not miss any new video that I put in the channel. Please subscribe and hit the bell. Okay, let's get to start with this question. Ionic compounds tend to be soluble in water. For example, the NaCl is soluble in water. Okay, let me use sorry about that. Use my laser pen. Ionic compounds tend to be soluble in water. The NaCl is a kind of the ionic compound, is soluble in water, but MgO is not. Why? So I want to answer why the NaCl is soluble in water and MgO is not. Let's get started. You know that the ionic compound, for example, NaCl consists of Na plus Cl minus, or the MgO like this consists of the ions Mg2 plus O2 minus. And the water, you know that the water H2O is a kind of the polar compound. Polar compound, because the the electronegativity of the oxygen is bigger than the hydrogen, and the electron cloud goes toward to the oxygen, and the oxygen get minus here. Look, partial positive charge here, minus -2 partial negative charge, positive, partial positive and partial positive here. So it means that the water is polar compound with two sides. I mean the positive and negative side. First of all, NaCl is soluble in water, because when you put the NaCl in the water, between the Na positive and the water with the oxygen side, because the oxygen is the minus OH2, you know, 2 and +2 partial. Between the Na and the OH2 and the Cl, there is a kind of the attraction between the Cl and the H2O with the side of the hydrogen, because the hydrogen is the positive, and 2 partial negative charge on the other side. The attraction between the ion, I mean the Na positive and Cl minus or negative, and the water, this attraction is bigger than the attraction between the NaCl alone and H2O alone. This attraction between the ions and the water is bigger than the attraction between the NaCl alone, because you know between the particle of the NaCl there is a kind of the attraction, this ionic attraction, and the H2 is a polar attraction. So this attraction is bigger than the NaCl alone and H2O alone. That's why that the solubility happened. But for the MgO, please pay attention here. For the MgO, you know, between the Mg2 plus and the oxygen of the water, there is a kind of the attraction, and between the O2 minus and H2O, there is a kind of the attraction. This attraction is smaller than the MgO alone and H2O alone. That's why that the MgO is not soluble in water, because the attraction between the ions and the water is smaller than the attraction between the MgO alone and H2O alone. So please pay attention. If we are talking about the salt that is soluble in water, you have to bring this story, the first story. The attraction between the ions and the water is bigger than the attraction between the salt alone and the water alone. But if you ask about the salt is not soluble in water, why? You have to bring this story, because the attraction between the ions, between the ions and the water, this is attraction, is smaller than the attraction between the salt alone and H2O alone. I hope that you enjoyed this video, and I will record a new video for you. Have a good time and goodbye.